Welcome. I'm René and I work for Bridge Diagnostics in Boulder, Colorado. In this session, we're going to look at STS-MONITOR. STS-MONITOR is built on top of STS Live, and I assume that you're familiar with STS Live. My colleague Jason has a number of instructional videos, and with the system you can run it in STS Live mode, so please follow these and make yourself comfortable with how STS Live operates. In this first session, I'm going to talk about the differences between STS Live and Monitor without going into the tests. In the following sessions, we will look at setting up a decimation test, followed by event recording, rainflow, and FFTs. Please follow the same order because I will switch from aspects of monitoring to more aspects of the test. FFT is getting quite complicated, and I hope at that moment you are familiar with how monitoring operates. The biggest differences in Monitor are the mode of operation. Monitor runs always, and Monitor runs on a site, and we don't have always a user interface connected to the site. In general, we don't. The user interface task is to set up the monitoring. But the monitoring itself runs on a program called the core on a separate computer. The user interface and the core communicate with each other over a TCP/IP connection. That may be a very fast Ethernet connection. It may be a dial-up system using a cell phone modem. Data is expensive to transport, especially when you're using cell phone modems. So the task for monitoring is to look at the data and only get the essential information of the data, prepare it for transport over cell phone modems. And that is what we're going to see in the following sessions. From a large amount of data which streams into the core computer, we are going to reduce the data so that we know exactly what happened, but with a very small amount of data. Let me show you some differences here. The first difference you can see is we have an icon here, and we can set the icon either in monitoring mode or we can go to live load mode. For this moment, I'll use live load. On this page, you can see that I have a very simple setup, one node and 3 channels with strain gauges. The strain gauges are mounted on a steel plate, and the steel plate is strongly undamped vibrating. Let's have a look at that. We can start the test. In just a moment. And I'm going to give an impulse. And you see that after the impulse, the system is a damped vibration. I can stop the test. Just like STS Live, this test is recorded. So let's look what our result is. We just made this test, open it up in Excel. Now look at the sensors. Let's make a graph of the 3 active sensors. Insert. And here we see basically what we saw on the screen. We will do this exercise a lot. It's the same structure as STS Live. All the data is stored in a dated folder, automatically generated by the system, and you can open them up in Excel. If the data is very large, other programs need to be used, but in general for these exercises we use Excel. We can close out here. I never saved the data because we have the original as a TDMS file. Close that out. And let's now look what happens in monitoring mode. First of all, you will notice that we have an additional page. This page is blank. This is the location where the test specification will be when we have specified test. If you did not specify test, nothing will happen. We'll switch to monitoring mode, save that. And we see here an additional parameter. The file length is now set to 1 hour. We can set the file length to quite long periods of time. The reason for that is that, for instance, if you run a decimated test, you only get a very low sample rate, but the test runs forever. So to prevent ever building file sizes which are unpractical to transport, you can terminate the length of the file in terms of hours or days. Everything else on this page is the same. If we start now a test without a test specification, nothing happens. There are no sensors. The core does not know what to do, so the test is immediately terminated. That is all for this session. The next session will be about actually setting up a test and doing some decimation. Thank you. Three-dimensional columns. And then here we have the data recorded. It shouldn't be much of a surprise what we are seeing here. Let me do that back. You see that all the cycles are counted over the mean, and we have a large cycle count because we have a vibrating system. That completes my demonstration of rainflow. Thank you for your attention.